Number of instantaneous center in the mechanism. The number of instantaneous center in a constant kinematic chain is equal to number of possible combination of two links. The number of combination of n links taken two at a time. Therefore, number of instantaneous centers en equals to n capital N equals to n into n minus 1 by 2, where n is the number of links. Types of instantaneous centers. There are three types of instantaneous centers. They are fixed instantaneous center, permanent instantaneous center. Third one is neither fixed nor permanent instantaneous center. In four-bar mechanism, I showed a figure. The centers I12, I14 are fixed instantaneous center. Hence, since they remain at the place same for all configuration of the mechanism, the centers I23 and I34 are called permanent instantaneous centers. The location of the centers are different for different configuration of mechanisms. That is, it moves when the mechanism moves. The links 2 and 3 and the links 3 and 4 have multiple connections at point 2, 3 and 3, 4 respectively, and they are permanent in nature. So this type of centers are called as permanent instantaneous centers. So the centers I13 and 23 are neither fixed nor permanent, since the links I13 at links 2, 4 have no material connection at these points, and also these points. Where is it concentration of these points? So these are known as neither fixed nor instantaneous nor permanent instantaneous centers. Arnold Kennedy theorem, or three line centers in line theorem. This theorem is called Kennedy's theorem. It states that any three bodies having plane motion relative to one another have three instantaneous centers and lie on a straight line. Consider three bodies A, B, C having relative plane motion to each other, shown in figure 4.6. Then n into n minus 1 by 2 by n is instantaneous center. Small n is number of bodies or links. Therefore, n equals to 3 into 3 minus 1 by 2, that is 3. Hence, it is proved that there are three instantaneous centers I, A, B, I, A, C, and I, B, C. Now we have to prove that these three centers lie in a straight line. I, A, B is instantaneous centers of A and B. I, A, C is instantaneous centers of A and C. I, B, C is instantaneous centers of B and C. The location of instantaneous centers IAB, IAC are known, and to prove that IBC also lies on line joining AB and AC, first assume that IBC lies outside the line joining AB and AC as shown in the figure. Now consider the point IBC on body B. Its linear velocity is BC, which is perpendicular to the line joining IAB and IBC. Then consider the point IBC on body C. Its linear velocity is BC, is perpendicular line joining IBC and IAC. Now, according to the definition of instantaneous center, instantaneous center is a point common to two bodies having same linear velocity in both magnitude and direction. Since the direction of two velocities BBC in a figure do not coincide, the points I and B, C cannot be instantaneous center of body B in a C. The direction will coincide only if instantaneous center lies in the same line joining IAB and IAC. Therefore, all the three instantaneous centers are on the same lines as proved.